Okay, so I'm just gonna start off by apologizing in case my dog cries. He really wants my attention right now. But I'm gonna go ahead and start with scenario 2. I'll go ahead and read it. Your male older husband has just arrived from the Principality of Sealand in the North Sea. You are sharing a malted at P. Terry's and notice that he has actually been covered in smallpox, a virus, since the moment you met. Upon this realization, your glottis contracts. Pouring your drink over the carina at the split of your trachea into your bronchi. This accidentally makes you force milk over your tonsils and mucous membranes. How does your immune system respond? So at this point, the basis is you've been exposed to varicella. Now, as far as it goes, I just drew like a subpar photo here of the mouth. And then, so you've basically ingested the virus. It's officially in your system. You have all these little viral cells here that want to replicate and just come at you and do their thing, do what they're supposed to. But naturally, our immune system is going to respond in the way that it was meant to. So it launches an immediate response. So we're not completely hopeless against the virus, even though they can't really be treated with antibiotics. However, our immune system, the innate immune system's first wave, is usually going to come by the macrophage. So the macrophage is going to come and try to engulf these virus cells here and try to basically take them in, get rid of them. And also, it's going to release interferons, signaling proteins that warn other cells to kind of lock their doors, basically lock themselves in from this invader that just entered into our system. And then moving forward, the macrophages and the dendritic cells, basically RBCs, they take a piece of the virus and display it on their surface, and they travel to the nearest lymph node so that way they can truly start moving into adaptive immune activation. And so at this point, the helper T cells recognize the variola and then become activated, beginning to divide and send out all these different orders and sending messages to the B cells and the cytotoxic T cells. Activated B cells then become plasma cells, transforming into antibody factories. They pump out specific antibodies designed to target the smallpox virus. And so the very specific antibodies to target those smallpox viruses are going to help prevent it from replicating and just kind of attack it like basically a missile would. And so it's going to bind to the viral particles and neutralize them. And then that tagging also helps other immune cells find and destroy invaders more easily. At the same time, our killer cells, like our KT cells, they get to work and they also start understanding that your body's been compromised and infected with this smallpox virus. And so they force the infected cell to self-destruct, preventing it from becoming that replication viral just factory that starts storming with more and more of these little viruses. But our initial response at the end of the day was just the macrophages trying to engulf the virus, as well as releasing those interferons to tell other cells hey, you need to make sure to lock your doors because this virus is not supposed to be here. Don't let them in. This is just a compromise to our environment. But in conclusion, while viruses can't be treated with antibiotics, we still have that innate and adaptive response in which we can help kind of mitigate all these effects that they have on us, such as the flu and COVID, and the one that we talked about here, which was the smallpox.